Hi everyone. Today we're going to be learning a little bit about some of the reliable data transfer protocols that are utilized on the transport layer to ensure data gets from the sender to receiver in one piece in order. We're going to start with a stop and wait protocol, the simplest of these, then move on to some of the more complicated ones like go back N and selective repeat. And looking at our setup here, we are currently looking at the sender. So you can see every other minecart rail represents either a packet, which has a TNT minecart, or an acknowledgement, which has a simple empty minecart. These packets and acknowledgements are sent underneath across to the other side where we can find our receiver in Oak. You can see those acknowledgement packets there. And these will be sent back and forth to each other to represent exchanging messages over the network layer. Next, we're going to demonstrate what happens in stop and wait, whereupon the sender starts by sending the initial packet over to the other side, and then we'll wait until the acknowledgement arrives. So first, the initial packet is sent. And as that packet arrives back at the receiver, they launch the corresponding acknowledgement back across. And the sender will wait for that packet to arrive, and as the acknowledgement arrives, it recognizes it, and then it launches the following packet. And just like before, the receiver waits for that packet to arrive, then launches the subsequent acknowledgement for that specific packet. And this process will continue to carry on until there's a failure case, such as a lost acknowledgement or a lost packet, or until all of the packets have been delivered. Let's take a look at some of those failure cases next. Next up, we're going to be looking at what happens when a packet is lost in transmission. So for this example, we're going to be using packet 1 as that lost packet. When we send it, it will not arrive. At the same time, we're going to be launching this timer over here on the right, this long minecart rail. When that chest gets back to the platform, that's how we'll know the timer's run out. This timer would theoretically be run on every single packet that is launched, but for this example, we're just going to be launching it on the packet that gets lost. That's packet 1. So, why don't we go ahead and get started by sending packet 0. And we can see packet 0 arrived, so we'll go ahead and send the acknowledgement for 0. And there's the ACK for 0, so we're going to send both packet 1 and the timer. And we're going to be watching that timer to see if it gets back before we get an acknowledgement message. And you can see here that the packet does not arrive at the receiver, it is instead stopped in transit. And thus, as the timer continues to tick on, we're not seeing an acknowledgement message since the receiver never got the message. You can see now that the timer's gotten back, we still haven't gotten an acknowledgement, so we're going to resend that packet. Hopefully this time it'll make it through. And you can see that it does. And the receiver receives the packet, so we go ahead and send the acknowledgement for the corresponding packet. And we're back on schedule just like we were in the original example of stop and wait, where everything was working properly. Alright, thank you very much for listening. Next up, we're going to be taking a look at some of the more complicated reliable data transfer protocols. We'll be looking specifically at go back N and at selective repeat. Thank you.